Today we're making object pools and memory allocators faster by using Freelist. Welcome back, friends. In my last video, I talked about object pools, which are an alternative to malloc and free style memory allocators. But as we left things off last time, our implementation of object pools was a bit slow. And so today I thought we would look at how we could actually speed things up a bit. The specific technique we're going to use to speed things up, that is Freelist, is not specific to object pools. It's actually something that you're going to see used all over in memory allocation. Probably the malloc and free implementation running on your machine, your laptop, your desktop, whatever and on your phone are probably using Freelist right now. Before we dive into it, a huge thanks to all of you who support this channel on Patreon. For those of you that are new here, that's where you can get access to all the source code from all my videos, as well as access to my monthly office hour. This channel is a side gig for me, and as I try to juggle this with my research career and teaching, I really do appreciate all the support. It really helps me keep doing what I'm doing on here. But now let's jump into the code. So we're going to start with essentially the same code that we had in the last video. Check it out if you missed that one. The only thing I've changed here, I have moved a few things around. One thing is, because I want to have a slow version and a fast version, I thought it would be easier to basically take my object pool and make it its own module. So we've got a header file over here. Hopefully this is nothing new. If you've been watching the channel, you've seen stuff like this, but we've got a header file that where we moved the number of objects definition, we removed the vector3 struct from last time over here, and we have our two functions, our borrow vector3 function, which allows the program to check out one of these objects, and then our return vector3 function, which allows you to return or to free that object when you're done with it. If we were looking at a more conventional allocator, then this borrow function would be replaced by something like malloc, and this would be replaced by something like free. So we have the header file. If you look in here, then this is basically just our code from last time. We have our implementations, we have our pool object, which is internally, the user never actually touches this, but this is what we use to manage the allocated state of our object pool. So you can think of this as our private implementation. Now, I haven't done it yet, but I do also want to make some changes. This is what our main program looked like in the last video, basically just going through and grabbing a couple of vectors each time. I do want to make some changes though, because this is only ever going to use the first two objects in the object pool. And as we discussed in the last video, the performance issues are going to get worse as we end up using more and more objects at a particular time, because we're going to have to work harder to find a free object. So what I'm going to do up here, let's just change this a little bit. And first thing I'm going to do is define a number of rounds. So we're going to go through and let's say we make this 100. Doesn't really matter. I just want to do enough work that we can time things. And then what I want to do is, rather than having this be 15, let's come down here and go through the particular number of rounds. And then each round, we're going to pick a certain number of objects we're going to borrow. This will vary things up a little bit. So let's say we have int numobj, short for num objects, and we will use rand. So this is going to pick a random number, and then we'll mod this by our number of objects. So this will pick a random number from 0 to number of objects minus 1. And then once we have that, let's also make an array of vectors, because we're going to have a variable number of vectors, and then we're going to allocate them, and then we're going to have to free them. And so let's make an array of pointers. These are vectors, and there are going to be num objects. Okay, so we've got our array. And yes, I recognize that using a variable length array like this is going to cause non-deterministic stack size. So like on embedded systems, which is where I may be using an object pool in the future, I might not actually want to use one of these in actual production code, but in testing code, it's going to be fine. And that's what we're doing today, is we're just trying to test these out. So then I'm going to come down here and have a for loop. Let's use j. And we're going to go to numobj. So we're going to go through the number of objects, and we are going to say vectors j. Okay, so the jth vector is going to be equal to, we're going to get assigned to, and we'll call borrow vector3 that many times. Okay, so this is the number of objects that we need from our object pool. And it's going to vary each time, each round. It's going to vary depending on what this rand returned at this given time. Now, normally in here in the middle, well, before I get to that, like normally after this, we would actually do something with these objects. Today, we're not going to do that. Let's just, before I forget, add in another symmetrical array that is going to return our vectors when we're done with them. And then here in the middle, we're going to, this is where you would do something with the vectors. What we are going to do simply for brevity is let's just go through and change this up a bit and say round. We'll print out the round number, and then we'll say, we'll just tell how many vectors we got. And this is because if I print out too much, then it becomes really hard to see what's going on. So yeah, so we'll have I in here, and then we'll have num objects. Okay, so this should work for my purposes today. Now let's just make sure that things are in working order. Yes, I'm having some VM issues. Ignore the warnings. The clock's queue detected. Should be fine. But if we run it, you can see, okay. So by adding a bunch of objects and a bunch of rounds, now it is a little bit slower. This is useful because I want to time this. So if I come in here and I say, okay, time this, we'll run it. And okay, so we're looking at something like 3 seconds, right? And let's just run this again really quick to make sure it wasn't a fluke. Yeah, so 3.5 seconds. Yeah, so anytime you're running something, you want to make sure you run it a few times because occasionally things can be a little bit slower, a little bit faster. You know, you're going to get some variability. So this is the baseline we're going to use for our Freelist example today. And at this point, you might be thinking, you know, a few seconds, that's not too slow. I can wait a few seconds. But we really are spending a lot of time searching through that array looking for a free vector. So if you, just as a reminder, when we come through here to borrow a vector, we're basically running through the whole object pool looking for one that is free, that's available, that we can then give back to the user. So we're spending a lot of time hunting through there as, you know, the more vectors. So like if I've got 8,000, 7,000 vectors that I have to grab, then it's really going to slow things down. And this is where a free list comes in. Okay, now the idea of a free list is to simply make a list, usually a linked list of some sort, that contains all of the free blocks that are available to be borrowed or allocated so that we don't have to hunt through a bunch of allocated objects, wasting our time before we find one that we can actually use. Okay, so let's look at how we can use a free list in our current example. Right here, I just have this empty object pool with freelist.c file that I created right here. That is going to be just like our object pool. In fact, let's just come in here and let's copy this. We're just gonna initially start out exactly the same. Let me go back to my makefile and add this. So now it's gonna compile two different versions of this. One that's just our base example, and one's our example with a free list. The rest of the makefile should be fine. By the way, if you haven't seen makefiles, check out my make videos for more information about how make works and how you can write your own makefiles. But let's look at how we can change this up to use a free list. Now, the first thing we're going to do is we need to change our structure a little bit. So we're not going to be using this Boolean anymore. That's like, are we allocated or not? Once we add a free list, we don't need this anymore. And that's because if an object is on the free list, that means it's not allocated. If it's not on the free list, then it is allocated. So we're just going to take this off, and I'm going to replace this with a pointer to a pool object, and we're going to call this next. Okay, and we need to add this. Otherwise, I'm going to get compiler errors. And at this point, hopefully you're saying, ooh, this looks just like the definition of a node in a linked list. And you're absolutely right, because that is what it is. Also, interestingly, today's example might be a good illustration of how linked lists don't necessarily have to go along with malloc. Sometimes students are so used to using linked lists in a particular way where you malloc a new node, and we're not going to do that today. So hopefully this gives you some added perspective on linked lists if you're new to that. Also, if you've never seen linked lists, check out my linked list video. I'll link down in the description. Check that out. But so again, the idea here is that our objects, when they're available, are all going to be on this linked list. And that list is where we are going to also return things when we're done. Okay, so the list becomes the place you look for free objects. Okay, so let's come down here. Our object pool is still going to be an array of statically allocated objects. That doesn't need to change. I'm going to add one thing here. We're going to add a pointer to an object, to a pool object, and I'm going to call this free list. This is going to be the head of our free list. So this is going to keep track of the beginning of the free list. For now, I just initialize it to be null. We're about to change that, but that's okay. Now at this point, we are going to need to add an additional function. We need some code in here to initialize our free list, because where before I was able to just like statically initialize everything to 0, and that was enough. Now we actually do need to set up this list. So let's make a function called initialize pool, and we'll have a quick little for loop that goes through our objects. And we want this to actually go through all but the last object. You'll see why in a second. And then I'm just going to say the ith element of the array, we're going to set its next pointer to be equal to the address of object pool I plus 1. Okay, so this is basically saying we want each node, each element, each pool object in the array, its next is going to point just to the object after it in the array. So this is how we're going to start out. It won't stay this way, but this is how we'll start out. And you notice we didn't go all the way to the end because the very last element in the array, well, it doesn't have a next element, it's the end of the array. So, and it's also the end of the list. So actually let's come down here and say object pool num objects -1. This probably is not necessary because we statically initialized everything to 0, but it's a good habit to initialize your variables. Okay, the other thing we need to do then is also set our free list to point to the beginning of the free list. And so the first object is going to be the first object in our array. So we could just do this because arrays and pointers are almost the same thing, but I do find this sometimes confuses students. So maybe another way to do this is to say free list equals the address of the first element of the object pool, okay? These two are gonna do exactly the same thing. They both work. I'm just throwing this in because I find that new programmers often find this a little more straightforward than this, but use whichever one you prefer. Okay, now we also need to run this. There are a few different options. We could have the test program actually call this code. We could add some tests to borrow and return down here, where we basically check to see if it's initialized, and if it's not, then we run it. Today what I'm gonna do is add an attribute. I'm gonna use GCC's, and Clang has it too, constructor attribute. This is going to cause this function to be run sometime before main begins. Let me know down in the comments if you want to see more about constructors and destructors in C. People often think that C doesn't have constructors or destructors, and well, it's not quite true. They're interesting, they're sometimes annoying, so that actually sounds like a really good topic for a future video. Anyway, let me know if you're interested. But anyway, now our free list is initialized, and this is going to be run at the beginning of our program before main ever starts. And so now this allows us, now we have this in place, this allows us to come down and change our borrow and return to make them much simpler. So first let's look at borrow 3 here. So borrow vector 3, we don't need a loop anymore, okay? We're gonna have a much simpler structure here. Let's just toss this and say, basically we're gonna say if the free list is not null, okay, so if there's anything on the free list, right? If there is, then that means there is some object available, and we're just gonna grab it. So then we are just going to remove the first vector from the free list. So I'm gonna make a temporary pointer called result and set that equal to the first element of the free list. This is the thing that we're actually going to return eventually, but we need to hold on to that for a second while we remove it from the front of the list. We then remove it by just simply saying free list equals free list arrow next. So this is going to basically just move the pointer from the free list objects to whatever the next element in the free list is. If we're at the end, that's going to just make it null. And then we simply then just return the address of results object member. So this is the vector that we're actually going to give to the requesting code. So the user called borrow vector 3, they wanted a vector 3. This object is a vector 3, so we're returning a pointer to that vector 3. But notice how much simpler this is. This is really nice. Like all we're doing is just popping it off. There's no searching. It's great. And of course, if the free list was null, then we return null, right? Because there's nothing to borrow, right? Our object pool is empty. If this was an implementation of malloc and free, we might go out and call mmap or something to get more pages and bring those in so you can actually grab more memory. Again, maybe an interesting topic for a future video. But so that's our borrow function. Now let's take a look at what happens in our return function. Now before we were doing a little bit of address math here to figure out which element in our array we're working with. We could also use things like the offset of macro here. Maybe another fun topic for a future video, but I think I'm just going to keep this here for now. I also think I'm going to keep this assert because, you know, why not? Sanity checks are useful, but this doesn't make any sense because we don't have an allocated member, and this doesn't make sense, right? Because we, again, don't have an allocated member. So instead of marking this object as not allocated, that's what we did before, now all we need to do is add this back to the free list. Now this is where students often overcomplicate things, thinking that you need to insert these objects in the order that they come in the array or the order that they originally were, and you don't. The point is that all of these objects are the same size, so the list order really doesn't matter. So what we're going to do is just add it to the front of the list every time, because that's simplest, and we don't care if this linked list gets a little convoluted. So to do this, what we're going to do is come in here and make another temporary pool object pointer, call it PO, and let's set it to the address of the object that we are returning. So the ith pool object, where we computed I right up here. And then what we're going to do is we're going to set, so the object we're returning, we're going to set PO's next pointer to be equal to whatever the free list currently points to. So if the free list is empty, then this is going to be null. If it's not empty, it just points to whatever the head of the free list is. And then we come in here and set the free list to now equal this PO. And PO isn't a great name, so let's say something like next object to add. Okay, so I like that a little better. So now at this point, once we're done, the object pool is the same as it was before, only it has the new returned object at the front of it. And that element, the one we just added, will be available on the free list for the next request to borrow vector 3 up here. Also note that one benefit of adding objects to the front of the free list is that it means that frequently accessed memory is going to be located near the front of the list, which may in some cases actually help our cache performance a bit. It's probably not going to make much of a difference, but it might make a little. Okay, so that's all we have to do to get our object pool to use a free list. Hopefully things now work. Let's come down here and just compile it all. It looks like it at least compiles. Let's come down here and run our new example. Well, let's run the old example just so I get a feel for what it's actually doing. Okay. And then let's run the free list one. First of all, you could tell it did go a bit faster. Let's time it and just see. And you can see that it's not a little faster, it's way faster. A few seconds didn't seem that bad until we now have an implementation that is taking, 20, 40, just tens of milliseconds. Like, this is a blazing fast implementation. And that's because it doesn't have to hunt through all those allocated objects. It literally just has to check the free ones. And it always finds the one it wants right at the beginning. Now, keep in mind that free lists work best. You're going to see the most dramatic improvement when the objects on the list are all the same size. If they weren't all the same size, we would have to hunt through to find one that works for us. This is why a lot of allocators, a lot of memory allocators, try to separate objects into different free lists based on object size. So if we have a free list, because then you can always just take the first one. So again, if you have a free list with objects of different sizes, you do have to hunt through a little bit, but you still don't have to go through all of the allocated objects. And so it's still going to be faster. It's just that in that case, the speed up wouldn't be quite as dramatic as what we're seeing here. So anyway, I hope that helps you understand what free lists are, how you can use them. Hope you had fun. Hope you learned something new. I hope this helps you in a future project. And until next time, I'll see you later.